Hi guys and gals. I'm going to be just putting in some videos that are going to break down the booklets for you. So I'll just kind of start uploading them as I go. So I'll just start with section 3.1. I know some of you have already gone through a lot of chapter 3 and then some are just getting started on it. So wherever you are, hopefully I can catch up and get some of those videos out to you so that you can start to work towards the future units. The other thing that I will mention is when you are finished a unit, so say you finished chapter 3 booklet, once you are finished, please email to me and I will get you a assignment. The assignment has 5 questions. Everybody's going to get their own version of the assignment. Once you're completed that assignment, you're going to either take a picture of it or scan it and send it back to me. And then I will assess and mark that assignment, and that will be what I use to adjust your grade. And always remember, you can only increase your grade. It won't decline your grade, okay? Yeah. All right, so I'm just gonna switch my camera around and start the video on this section 3.1. All right, so we are gonna go through chapter 3, surface area, volume, and capacity. This will be the 3.1 video just on surface area of prisms. So you've got, first we're gonna be looking at squares, rectangles, parallelograms, triangles, and circles. So your basic two-dimensional shape. I'm going to just flip over the page here. There are some quick examples. An example 1, and then it does give you this page of formulas. I would, if I were you, I could either just take it out like I did so that it's easy enough to access, or another option would be to start making a sheet where you can have all of your formulas and things like that on there. Because you aren't needing a cheat sheet, if you want to just pull that aside, you can do that. And then you have on the very next page just some examples that you could go through. They're pretty simple examples just to get the hang of doing the formula and using the formula for two-dimensional surface area. I'm just going to quickly go through number 2B, which we've got a parallelogram. If I look at my formula is going to tell me that I need to go A is equal to the base times height. So if it's just a B up against an H, that means you're multiplying those two. So I'm going to go ahead and multiply 5.2, which is my height, so I've reversed them, I guess. And my base is the 8.5. And when I multiply those, I should get about 44.2. And then I always want to include my units, which is going to be meters squared in this case. Okay, you can go through some of these other examples if you like. With triangles, it's base times height times 1/2, or 1/2 times base times height. You can either use 0.5 or you could use divide by 2, right? And so always use your perpendicular height and your base. So in these 3 here, this is my height, this is my height, and this value out here is my height. I do not need to find a slanted height like that. I want to use the perpendicular height. Okay, so I am going to move on. I'm going to kind of just browse through this quickly. You start to see these types of examples. What you can do with that is you can start to split them up into two-dimensional figures that are easy to calculate. So I won't go through that example because it is there for you. There are numerous different ways that you can often set these up. You'll notice in the example it set it up with the rectangle here, a larger rectangle, and then a triangle, whereas in the alternative solution it has the triangle, but then the 2 rectangles are slightly different. You may have to do some calculations as far as figuring out length of things. So like in this case, if I was going to go find out this amount, that is just going to be 13.4, take away the 6.2. So like I said, I am going to just run through that because you do have the solution there to check out. And we're gonna move on just a little bit further, and I will quickly look at this example here. So it's number 4. This is on page, let's just double check here. Tell me what page. Should somewhere. I think that's page 131. So what we've got there is we could separate this. We could either draw a line this way and here, or we can draw a line down like that. However you choose to do it is perfectly fine. There are possibly some other measurements we may need to figure out. For instance, I do have the measurements for this section. That is just going to be 6.2 times 4.6. The middle section, to figure out those dimensions, what I may have to do, because I don't know this amount here, what I can do, I'll just do this over on the side here. The bottom is 8.8 all along the bottom. And if I take away these two amounts, from 8.8, I am going to get some of those amounts. So I would get, I believe it would be 2.4. And then also along the side here, if I go 6.2, take away 3.6, then what I'm going to have is going to be, I think it's 2.6. Yeah. So now for that section, I'm just going to kind of do that. We would have 2.4 times 2.6. And then my very last rectangle, which is there, is going to be the 1.8 along the top, and then this same height, which is 6.2. Then it's a matter of multiplying each of those, and I would get this first one, do a quick calculation, 28.52. Do a quick calculation, 2.4 times 2.6, and I would get 6.24. And lastly, I would have 11.16. Then it's a matter of adding all of those together. So 28.52 plus 6.24 plus 11.16. And in the end, I should get 45.92 meters squared. So that was just an addition. That should be my answer for that one. Okay, moving along. Now this page here, it does talk about just naming different three-dimensional figures based on what shape their base is and what kind of lateral faces they have. So when they talk about lateral faces, that is going to be like the side faces. So either going up and down, or like here you've got a rectangular lateral face but a hexagon. Here it's just a square rectangular, so rectangular prism, hexagonal, right hexagonal prism, a right triangular prism. And then we have here, if it's on a bit of a slant and it's not like a right angle, those are called oblique. So in that case, we would have an oblique rectangular prism. Okay, I'm not going to get too hung up on that stuff at the moment, so that you can continue on if you want to check out this chart. It just, the shape of the base, sorry, just looking at the chart there, the shape of the base, maybe a triangle or a pentagon or a hexagon or something like that, maybe even just a rectangle. Is it a right or oblique? So do they have right angles where they meet? Is the shape of the lateral faces rectangular? And the name of the prism, such as right triangular prism. Okay, moving on just a little bit further here. Make sure my paper is in. We're on 134. The nets. So just to answer this question, because I know a lot of you guys will have this question, do we have to draw the nets? That is up to you. If you feel like you need more practice drawing the nets so that you can visualize all of the sides, such as in this case, you've got like a house type shed thing. You may want to draw out all of the rectangular sides, even the bottom. So there's one on this side, a matching one on that side, and then two matching sides and a bottom. And then those two front faces with the pentagon. Okay, so you've got the visual there. If you would like to draw out the nets, go right ahead. If you do not want to draw the nets, I'm okay with that. Okay, so if it helps you, go for it. If it doesn't, not a problem. So just moving on a little bit further here. There are some you can draw their nets and do a quick calculation. You can see that I've done this one here just to show that there is 3 different ways, or possibly more, that you can draw a net. Okay, just gonna move on though to this question with the trapezoid. One thing you may not notice is we need this side length, and it does not give me that side length, so I do need to make a calculation there, and then I can calculate all my rectangles that go around. So in order to calculate this side length, I'm just gonna over to the side here, recognize that I have a right triangle with a right angle, and my height of that right triangle is 8, and that little bottom is 1.5. And if I use the Pythagoras theorem, 8 squared plus 1.5 squared, well, I get 66.25. Not quite done. I do need to square root that, and when I do, I get approximately 8.14. So that's going to help me with the rest of my calculation, because now when I go to do the calculation of this side and the other side, I will have that length of my, or width of that rectangle, right? So now I can actually calculate this side, which now I know is 8.14 times my height, which is 15. And I know that I have 2 of them, one on this side, one on the other side that I can't actually see. Do a quick calculation of that. I've got 244.2. Then I've got a few other rectangles going around. I've got the 9 by 15. Do that one as well. 9 times 15, I get 135. And along the back, I want to calculate that one as well. Now I know that this is 9 right here because it's the same as down here. And I have these little sections of 1.5. So a quick little calculation of 9 plus 1.5 plus 1.5 is going to equal 12. Okay, so along the back there, it is 12. So I'm going to go 12, and again, this is still 15 centimeters, and I will calculate that, and I've got 180. Not quite finished yet. Then I want to go ahead and calculate the trapezoid that is on the top, as well as the one that would be on the bottom. And the very front, that formula page, it does have this formula here, which is an option, or you can think about it as calculating this rectangle plus these two little triangles on each one as well. Either way, you will get the same answer. So I'm just going to use the formula. We know that the formula is 1/2, and then you've got an A plus B times your height. Now there's two of those trapezoids, so I'm actually going to go 2 times the 1/2. My A is 9, and my B is this backside, which is 12. And then times that by my height, which in this case is the perpendicular height of 8. So a couple quick tricks that I like to do is when I've got a 2 times 1/2, I know that 2 and 2 are going to cancel out and make 1. So that doesn't really adjust or affect the rest of my multiplication. Then I've got 9 times 12 times 8. I can do that all in one sweep. And in that case, I would get this is 9 plus 12, which is 21. 21 times 8 is going to give me 168. So I'll just add that to my addition of adding up all of the sides there. And when I do add all of those together, I should get 0.2. Adding the rest, I've got 707. And again, just making sure for full marks, I've got my units and the fact that it is squared. Okay, moving on, because this video is getting a little long. Going to skip over that. This one here I did do, and I dropped a picture in one of the comments on the posts page. So if you scroll back, you would see that, and there will be a picture left there. The last question that I do want to look at, actually two things I do want to just mention. With these word problems, such as this one here, you're going to have things like, what is the surface area of paint that is going to be required? Well, that's easy enough. I'm going to calculate the surface area of a rectangular prism using my dimensions. However, 1 gallon of paint is approximately 255 square feet. So how many gallons? What you can do there is take your total surface area and divide it by the 255. And that is going to tell you how many gallons you need to purchase. Now, once you know how many you're going to purchase, you can go ahead and multiply how many gallons of paint you need by $55.4. So in that case, you would want to round up your gallons of paint because you can't just buy partial gallons of paint in real life. So do consider the real life factor. Please go through that example. If you have questions about it, ask me. Okay, and the very last example for this video that I'm going to go over is number 11, and that is on page 145. Number 11 is another quick example. It just says that Amir is building a storage chest in the shape of a rectangular prism. The chest will be 90 centimeters by 70 centimeters. So you may want to draw yourself a little diagram. 90, and it is 70 centimeters deep, 70 and 60 centimeters high. That might give you a bit more of a visual. And then I can go ahead, and I know that I've got a bottom and a top, so two of those are going to be 90 by 70. Then I'm going to have two sides, right side and left side, and that is going to be the 70 times 60, and 2 times my front and my back, which is 90 times 60. So in this case, just make sure you don't have the same two numbers multiplied by each other more than once. Notice that they are all a little bit different combination. Do my quick calculation of each of those, and I have 126. Oh, too many zeros. And 21,000. And lastly, 10,800. Add all of that together and you've got 44,400 centimeters squared. Now if it says he needs to buy 20% more wood to account for any kind of waste, remember to change your percentages by dividing them by 100. So now you can go ahead and multiply the surface area by that value, 20%. That gets you 8,880. But I just need to finish off my question by adding that on. And so in total, that is how many squared centimeters of wood that would be required to build this chest. In real life, we might actually change that into meters, but we won't get into that in this video here. Alright, so I'm going to end the video off there. You can find the next video for 3.2 just in the list of videos there, okay?